Through problems 1 through 5 on the AMC8. So problem 1, there's an 8-pointed star, and we want to find what percent of the entire grid is covered by the star. So, well, 1, 2, 3, 4. So it's a 4x4 grid. There's a total of 16 different squares, and let's see how many squares are not covered. So this square is 1 that's not covered, 2 not covered, 3 not covered, 4 not covered. These are each half squares, so 4.5, 5, 5.56, 6.57, 7.58. So there's exactly 8 squares that are not covered, so there's exactly 8 squares that are covered. And so 8 squares out of 16 is 50%. Next question. The table below shows ancient Egyptian hieroglyphs that are used to represent different numbers. And so we have an example of what the hieroglyphs actually are. It's basically just Roman numerals, but they're using different symbols here. And you want to decode this. So this is a 10,000. So that's a 10,000. Plus, well, this is 1, 2, 3, 4 of this 100, so 10,000 plus 400, and then this right here is a 10, so plus 2 times 10 is 20, plus 3 times 1 is 3, so it's 10,423, that's B. Buffalo Shuffle is a card game in which all the cards are distributed evenly among players at the start of the game. When Anika and 3 of her friends play Buffalo Shuffle, each player is dealt 15 cards. Suppose 2 more friends, we want to find how many cards will be dealt to each player. So let's find how many cards there are in total. When Anika and 3 of her friends played, that means there's 4 total players. Each player is dealt 15 cards, means there's 4 times 15 equals 60 total cards. When 2 of her friends join the game, that means we get 6 total people joining the game. And we want to find how many cards each person gets, such that there's still going to be 60 cards. We're not magically adding or removing any cards. So, well, if we just do the division here, that means there has to be 10 cards per person. Lucius is counting backwards by 7s. His first 3 numbers are 100, 93, and 86. What is his 10th number? We can literally just count backwards by 7s just like Lucius. Second number, third number, fourth number is 79. Fifth number is 72. Sixth number is 65. Fifth number is 58. Fourth number, or 1, 2, 3, 4, 5, 6, 7. So we need 3 more numbers. So let's just write 3 more numbers. 51. Then it's going to be 44. Then it's going to be 37. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 37. That's answer B. Literally just counting backwards didn't take that long. Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Betty starts at the factory and drives to location A, then B, then C, before returning to F. What is the shortest distance she can drive to complete the route? Well, it doesn't really matter here. What matters is that, well, the shortest distance is going to be a loop, and it actually turns out that it doesn't really matter what the loop is as long as we're not looping around, as long as we're not going like this or something. As long as we just take the shortest route like this and then the shortest route like this. It doesn't actually matter all that too much what the actual route is. This is the same route as going like this, or you could go like this, and it really doesn't matter as long as we don't make these extraneous loops that we don't really need to. So let's literally just count the number of blocks. So 1, 2, 3 gets her to A. Then, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's 24. That's the first 5 problems.